Greetings, everyone. I am Dr. Angela C. Arguson from FEU Institute of Technology, Philippines. On behalf of my co-authors, okay, I will be presenting our paper entitled Visualizing Ocular Trauma Causes in the Philippines, a heat map analysis. For the introduction, eye injuries are a major preventable cause of loss of sight, and it's critical to identify the risk factors and characteristics of this occurrence to avoid injuries. Every year, over 2 million incidents of ocular trauma are reported, with over 40,000 resulting in substantial loss of vision. Ophthalmic trauma is associated with various factors such as geographical location, culture, and social economic status of the population. A 15-year retrospective study from Portugal discovered that in addition to gender and injury location, economic status may be a high-risk driver. In Greece rather, a 4-year study was conducted and revealed that patients with no formal employment had higher rates of occupational injuries. Interestingly enough, various authors from different nations have benefited from heat map visualization as valuable tool in terms of retinal disease diagnosis software. In South Korea, others, posterior pole software in Spain, and transcriptional profiling for identifying pathways in retinitis pigmentosa in Germany. In the Philippines, the previous study on ocular trauma was centered on quality of life after treatment. The Department of Health East Avenue Medical Center, or DOH EAMC, is committed to provide the highest standard of hospital care. Challenged by their goal, the said healthcare industry agreed to have a joint study with FEU Institute of Technology way back in 2018. This paper aims to develop an interactive web-based application that will provide visualizations and efficiently ease the task of electronic record data entry operations. Considering the predicament cited, okay, the paper sought to answer the following question. Number one, what are the number of patients experiencing ocular trauma in the Philippines? What are the tools and methods needed to develop the system? How will the system provide visualizations to ocular specialists? And how will the software developed be evaluated by DOH, doctors, and computing professionals? For the methodology, the research design, okay, a descriptive developmental approach was employed in this study to develop the system and conduct the study. The respondents and sampling technique. There are two DOHEC official specialists serve as the respondents and help provide useful insights in the development of the system, which led to employ convenience sampling method. In addition, 11 computing professionals also served as technical evaluators of the system to ensure that it adheres to software quality standards. Data collection and ethical concerns. The authors formally coordinated with DOHEC or DOH physicians, okay, for software requirement elicitations through emails, face-to-face meetings, and virtual communication channels to ensure data quality along its confidential structures were handed with consent and that it will be protected. Software paradigm. The developers choose to employ Scrum developmental approach to design the computing solution. The software development was checked against the schedule of a 30-day sprint along with the designated Scrum meetings and software requirement backlog reviews. Evaluation instrument for the DOHEC respondents to assess the developed system and ensure the quality of the software. The authors provided the technology acceptance model or TAM as the evaluations instrument. Moreover, the ISO 25010 was selected to evaluate the developed web-based system by the computing professionals. As seen on our screen, the results and discussion, okay, it presented the table one, okay, and as shown in this table one, the software was tested and approved by the DOHEC physicians by reviewing the software requirements documented against their interactions as part of the checkpoint meeting. After 10 months of using the system by its respective users, the system was able to provide more data that is very useful in data analysis. The web-based application provides a dashboard to allow users to interact with the system and access features such as encoding, to create reports, viewing reports, view analytics, user management, view audit trails, and workplace management services as shown in figure 3 to 9. The evaluations for software quality and user acceptability succeeded in the development phase. There are two DOHEC consultants who participated in the acceptability, mainly due to their role in being the focal person to use the said software using the TAM instrument, as seen on Figure 10. Table 2 shows the acceptability of the evaluation done by the two DOHEC officials, which are primary users of the developed ocular trauma registration. Both evaluators highly recommended the use of the software to augment to their work. Table 3 shows the acceptance evaluation done by the 11 computer science and IT professionals, okay, of the developed software using the ISO 25010 instrument. And it can be derived from the table that the majority of the evaluators agree that the software is of high quality and has a low chance of debugging tasks to be done. In conclusion, okay, therefore, the authors prove that the web-based ocular trauma with visualization system was efficient in assisting the DOHEC officials in encoding ocular injury details with their smartphones or laptops. The system was equipped with heat map and supporting charts that will aid the DOHEC physicians better understanding the situation of the patient better and faster. However, it can be noticed from the dataset that both evaluation was seen as too limited since the authors wanted to have a focus group to check on the system with the intention of acceptance and deployment. Next, in response to that, here are the answers to the questions. What are the number of patients experiencing ocular trauma in the Philippines? Using the system, okay, there are 1,036 recorded ocular trauma occurrences, where 19 of them were male and 81 were female. What are the tools? Or question number 2. What are the tools and methods needed to develop the system? The developers used web development tools, okay, to develop the system and be able to build a dynamic website. Okay, they also adhere to the Scrum methodology, which aids the developers in organizing tasks and respond adaptively in short sprints. Uh, the Gantt chart really helped the developers with monitoring their progress and upcoming tasks over a span of 2 consecutive years. Research question number 3. How will the software provide visualizations to ocular specialists? Upon successful login as an administrator or registered ocular staff, the dashboard will be provided to start the interaction of the preferred visualization. Graphical presentation of certain analytics will be provided, such as heat map analysis, demographic analysis, eye injury sources, eye tissues involved, and visual acuity. How will the developed software be evaluated by DOH EAMC, doctors, and computing professionals? The software the software was evaluated via online and face-to-face sessions, both for the end users and computing professionals. The majority of the evaluators agree that the software was very satisfactory, rating both on the software quality and user acceptance. On the recommendation, a recommender system that prescribes certain actionable insights based on historical data was one of the recommendations coming from the evaluators. What else? Number two, a bigger capacity for data server to cater an approximately more than 10 years worth of data. Number three, dynamic chart selector that will provide visualizations to match the preference of the head physicians. And number four, inclusion of visualization in an aggregate form to display heat map analysis of occurrence per region. And with that, I end my presentation. Thank you very much for listening.